we're going to learn how to take a set of parametric equations and eliminate the parameter. Here, I'm going to go to a whole new page. Here we are. Okay, so eliminate the parameter. So what that means is, when we actually graphed this, it was just on an XY graph, and it just, we used t to figure out what the x and y values were, but otherwise t is not in the graph at all, right? Do you guys think there's a way to graph this without even having t as part of the problem? Could we write an equation for that line with just x and y that doesn't have t in it? Could we turn it into just a regular rectangular function? Yeah, we should be able to. So let's take the same exact problem, x equals 3t minus 2, and y equals t plus 1. And we want to get rid of t, so all we have is x and y. Anyone have any ideas on how we could do that? Jordan, what do you think? Can you think of a way we could do that? X over t, no. I don't know. Oh, so you're thinking we should solve the system?
No.
That might work. Instead of doing elimination method, though, I think it would probably be... Oh, so you're saying do elimination method eliminating t.
Yeah.
Oh, I see. Yeah, that would work. Okay, usually I just show this using substitution method, but elimination method would work really well. Okay, can I just show you using substitution method? Alright, so what I want to do is solve one equation, one of the two parametric equations for t. Which one's going to be the easiest to solve for t? The y one is. So t will equal y minus 1, correct? Now we can substitute that for the t in the other equation. Okay, so Jordan, tell me what it's going to look like. What should I write next? Perfect. X equals 3 parenthesis y minus 1, because we took the y minus 1 and plugged it in for the t, and then a minus 2. Candace, what's our next step? Oh, and you're having a hard time seeing today, too. No, you're fine. Okay, so Cody says distribute, so we would end up with 3 times y is 3y. 3 times negative 1 is negative 3 minus 2. So x equals 3y minus 5. Now, is that usually how we write an equation when we're dealing with x and y?
No.
What do we usually do? So you probably want to finish this by solving for y. So that would give you x plus 5 equals 3y. So that means, final answer, y would equal what? 1/3 x plus 5/3. Okay, now based on the restriction we just talked about, on the problem we did before, we said that the restriction was that t was from 0 to 3. Is this graph going to have a starting and a stopping point? No, it's going to like be forever, both directions. So how do we actually make it start and stop where we want it to? Okay, but there's no t in the problem, so saying anything for t at all doesn't make sense, because t is now gone. So we just need to deal with x and y. How can we define starting and stopping points just using x and y? Do you remember our table we did earlier? Here. So here's the table we did earlier. We plugged in from 0 to 3. So t started at 0 and ended at 3. X started at -2, ended at 7. Y started at 1, ended at 4. So how could we define this to start? How could we define, and since we solved this so it's plugging in x, wouldn't that mean that defining the domain would be best, right? So where x is such that, where would x start and stop? What did we say from our table? Starts at -2 and goes to 7. So instead of taking values of t and plugging in 0 to 3 to know where to start and stop, since we've gotten rid of t, instead can we know where to start and stop by plugging in a -2 for the x and a +7 for the x, and then that gives us our beginning and ending points instead of it going forever, right? So the tricky thing with changing a parametric equation to a regular equation is that you usually have to restrict the domain. Not always, it depends. Now if t had been all real numbers, would it matter? If t had been any value, all real numbers, then it wouldn't matter at all because this equation would just go forever and the domain would also be all real numbers. Right? So this is just if there's a restriction that you need to state the domain. So I'll just make a note of that. Okay, let's do another one.